Hello friends, today we are going to discuss a very new concept in economics, namely glimpses of software economics. In my initial presentation, I'll be trying to tell you about the content of my entire topic. I will be discussing individually the components in greater detail, and I shall end the entire presentation with a small summary. In order to understand this new concept of software economics, initially we'll try to discuss about the flow of economics to the new area of software economics. We shall try to understand in the second component, based on the flow diagram, the content and the scope of this subject called as software economics. Then based on this, we shall try to discuss a new concept that has been introduced in this particular field, namely the concept of ultra high programmer productivity method, the use of it, and based on this, what are the few propositions which have been actually made in this particular discipline, we shall try to explain and then try to end the entire presentation with the help of a small summary. Before we try to understand what exactly is the concept of software economics, initially let us start with having a brief discussion about what exactly economics is all about. As we all know, economics is nothing but a science which tells you about management of resources. And in this subject, we normally consider four resources or four factors of production, namely land, labor, capital, and organization. The best combination of the resources which can be used to produce a given level of output is what is being discussed in the entire content of economics. Now, this has been linked with the software industry with the help of the extension that is given to a discipline of software engineering. For example, let us consider software engineering. What exactly it deals with? It actually develops programming in a well organized manner and encompasses the technical and programming components of software development. So software development in particular focuses only on the engineering or the technical part of the entire software development cycle. Whereas in software economics, we look at the entire development life cycle of the development of software from a new approach, and the management angle is added to this particular discipline of software economics. So what is the entire attempt of this software economics? It tries to modify the life cycle of software development, and during the process it tries to optimize the resources which are utilized during the process of software development. Now the resources, as I already said, are considered as land, labor, capital, and organization. Now the angle of introducing the economic component to the cycle of software development has not been done by an economist. An economics person linking his subject to the software engineering is not the direction, but a software engineer, namely Leonard Levy, who was as a software engineer at AT&T and Bell Laboratories, he tried to conduct a research on the application of economics to the aspect of the software development. What is the basic objective of this particular entirely new discipline called as software economics? The basic objective is to optimize the productivity of resources used in the process of program development. Now, what does it actually demonstrate? It tries to explain how to apportion the development cost among the different phases. Now, when a software is actually developed, or when the software is being developed, number of resources are involved, and there is a cycle of development. And in this cycle, the optimization of resource utilization is what is being discussed with the help of various laws and various principles and various theories in economics. So the theories and laws of economics are being applied to optimize the production cost of a software development. Now, what exactly is the entire focus of this particular subject? Namely, management of programming process, or in simple words, the resource allocation and planning is what is the basic focus, and there is a managerial and economic aspect of software engineering. That is what this subject is actually recognizing. The flow diagram given here very easily explains to you the interrelationship between software engineering and software economics. The right hand side of the flow of this particular diagram clearly indicates that software engineering deals with the programming part of it. Whereas the left hand side of this particular diagram tells you that there is a managerial component also. And this managerial component together combined with the programming component is what gives you the content of software economics. Now this is entirely a new approach of looking at the life cycle of development of a particular software, and the justification of using the laws and principles of economics for software project cost optimization is based on some theorems and principles which have been designed and which have been studied, examined by the software engineer, namely Leonard Levy in AT&T and Bell Laboratories. Now, what exactly is this new particular concept called as UHPP? This UHPP, in full form, it means Ultra High Programmer Productivity Method. This model assumes that some methodology for producing the software very economically exists, but that methodology is applicable to few part of the fraction, possibly almost all of the project. Or in simple words, during the process of software development, let us assume 10 software engineers are actually employed. Now this method of ultra high programmer productivity method emphasizes that the entire 10 people may not be allocated for the software development. 8 people may be working on the technical or the engineering part of it, whereas 2 people can be allocated for designing new tools which enhances the productivity of the existing 8 software engineers. So this particular model assumes that there can be a new methodology of developing the software which enhances the productivity of the existing software engineers and thereby reducing the project cost. Now this has been emphasized by the software engineer, namely Leonard Levy from AT&T and Bell Laboratory, USA. He says a very substantial gain, programmer productivity, can be obtained or achievable by appropriate resource allocation. Now this resource allocation component is what is being emphasized with the help of laws and theories in economics. Now this requires a significant fraction of any project to be dedicated to enhancing productivity and construction tools. Or in simple words, if 10 software engineers are working on the project, very simply it says that 8 people should be given the technical task and 2 people should be allocated for discovering new tools for enhancing the productivity of the existing 8 software engineers. Now, as an example to understand what exactly is the discipline of software economics, we try to explain only 3 propositions. Now, there are a number of propositions which has been given by Leonard Levy in his particular book, namely Taming the Tiger, Software Engineering and Software Economics, and from that we are only highlighting only 3 propositions which try to emphasize the significance of this new discipline. The first proposition, which I have identified as proposition 1, it says if a software is developed by using a ultra high programmer productivity method on a small portion of the software cycle K, then the overall productivity gain is indicated by gamma given as G by K plus G into 1 minus K. So Leonard Levy has developed a formula to compute the overall productivity in the life cycle of a software development when a portion of the software is developed by using ultra high programmer productivity method. Now this, in that pictorial form I have indicated, wherein the life cycle of the software is explained by movement from the point A to the point B. From point A, the starting, the completion of the software development cycle is at the point B. And let us indicate a small portion of this particular software by C, and let us assume that on this small portion K, ultra high programmer productivity method is applied. So Leonard Levy has given us a formula to say that this, if we apply this particular ultra high programmer productivity method on the small portion of the software, then the overall productivity of the software increases by gamma, and the formula is given as G by K plus G into 1 minus K. So if at all, let us say 2/3 of the software is developed by using the ultra high programmer productivity method, then easily we can calculate the overall increase in the productivity because of this first proposition. So this is how he is emphasizing the application of new productivity enhancing techniques. This is what the first proposition summarizes. Let us try to see what exactly is the second proposition. It says much more benefit is derived from extending the domain of applicability of ultra-high programmer productivity than from increasing the productivity gains from these individual techniques. So put it simply, this says that if we again go back to this particular line diagram, A to B, it says that instead of trying to maximize the benefit by using ultra-high programmer productivity method only on K portion, it is always better to extend the domain of application of this productivity enhancing method from K to B. That means from C, if this is moving towards B, means we are trying to enhance the domain of application of this new productivity enhancing technique, and that results in a higher gain. That is what Leonard Levy has found out, and he has given in the form of a theorem this particular proposition. So this is not just an oral statement, but it is a verified fact that when new productivity enhancing method is being applied and its domain of application is increased, the overall productivity of the software development cycle also increases. So here we are not estimating the cost, but we are trying to talk about the efficiency of the individual programmer, and we are also talking about the enhancement in the software development life cycle process. Now this is what is the second proposition. The third and the last proposition, which I would like to emphasize to see that how this new discipline has become recently very much important and is being studied in almost all the universities. The proposition third says the gains from applying two different productivity enhancing techniques, namely M1 and M2 simultaneously, is greater than the productivity gains obtained due to M1 and M2 separately. So that is what is in verbal form. It says that if two different productivity enhancing techniques are discovered by the software company and they are simultaneously being employed on the same software life cycle, then the benefit is much higher than individually applying them on different phases of the software life cycle. That means when two different productivity enhancing methods are implemented simultaneously, this results in a synergy effect, and this is called as a synergy factor. Now this is summarized in this small equation wherein says that productivity gain, namely gamma 1 2, means applying two methods simultaneously is greater than applying the two productivity enhancing method separately, namely gamma 1 and gamma 2. So we have earlier seen the basic content of what economics is and how software engineering and software economics are actually interrelated, and how this has become a new discipline which has been used in the which is being now currently being used in the software industry in order to optimize the cost of the programmer productivity. Now in summary, we can easily say that economics is primarily a science of choice, and software economics provides methods and models for analyzing the choices that software projects must make. It does not deal with development but deals with the productivity and the quality of the software. Now this quality and the productivity aspect which come from the management point of view are being used for enhancing the programmer productivity and reducing the per unit cost of the software development. Therefore, it can be easily said that a significant fraction of any project should be dedicated to enhancing the productivity and construction tools of the software development life cycle.